we could start this video by saying, can you tell what it is yet? Well, what it is the next job from the batch which came yesterday, straight from eBay, but for a customer of mine. So this has come with side screws, and I've done this on the video deliberately because I'm very good at losing side screws. We'll put those to one side. In fact, I'm going to put them in the soldering iron thing where the sponge is, just so that we both remember. Now the mic, despite very careful packaging, hasn't done too well, and the customer said don't touch it, so I'm not going to touch the mic. We'll see whether it works, because it you know, as far as it should work. If it doesn't work, we'll use the standard mic, and I'll just send it as it is with no service work whatsoever to that. And what we have is the Cybernet Beta 1000, and it is a Cybernet Beta 1000. It isn't a Ford Roadmaster. I don't know where that sticker's come from, why that sticker's come from. The eBay listing doesn't say anything about Ford. I think it's no more a Ford than if somebody would put a Coca-Cola sticker on there. You know, it just happens they've probably made the mistake of having a Ford car and they wanted a sticker to go along with it, you know. That was good, wasn't it? Anyway, I thought it meant fixed or repaired daily, because you can come up with this for every type of car, can't you? Says I, going round in a 22-year-old Toyota Corolla. Okay, let's get this unscrewed. I'll put the soldering iron on because chances are that it's going to have a speaker that needs unsoldering. Well, that looks alright. There doesn't look anything inherently dodgy. This could be the quickest one we've ever done. I haven't even got my notes out as to what's what. We'll muddle our way through it. We'll plug in what's left of the mic. And we'll switch on. Of course, my power things are shorting out, aren't they? Because I've gone and turned the radio round twice, haven't I? Let's try again. Okay, so we're on channel 20. We'll plug the instrument speakers in. This is going to be a pain. Right, whether the customer likes it or not, we're going to untwazzle this power lead. I can't work with a 4-inch power lead. I'm sure he wanted the pleasure of taking that tape off himself. Right. Is the One Heart Cat's pen again. Right, picture in picture on. Let's see what it's doing on transmit. Oh. The answer is it's not doing anything on transmit. what we'll do is we'll put my standard mic on, just so we know that's right. And it's just the same. Okay, so let's go over to receive. It doesn't transmit at all. I'm taking somebody to hospital tomorrow, to Boston. Somebody from church who rings the bells. And so it depends how long he's at hospital, so don't know what we're going to do tomorrow. Because you know, he might well have an appointment at 11:45 or something, but things can happen. So imagine if they take one look at me, they'd have me. Hey, I tell you what, I got my hair cut today, so for the first time since last March, I managed to get my hair cut. What I didn't want to do was to kind of go to the barber's day one and kind of queue or book or even pay one of the test meters fell on one of the microphones. Or pay an inflated price or something like that. So there was only one person in front of me and everything was fine. Okay, so we're doing receive. And we don't have any receive. So we've got no transmit and we've got no receive. Well, it looks like we're going to have to print off some of the information. I think what we'll do, we'll put the spectrum analyzer on. And we'll just kind of sniff around the VCO. I'll unplug that extension speaker because what's going to happen is when I press transmit, it's going to go into feedback, as we know. So I might just be able to pick up that it's doing something. It may be that one of the voltage rails is missing, like the 8-volt rail. That could cause lots of things not to work. But it's so impeccable inside, you know, you can see it's never been fiddled with. So I don't need to just go around twiddling things because that isn't going to be the answer. Something has happened. So what I'm going to do is we'll just put that there. Let's go to put picture in picture onto the spectrum analyzer. I'm going to press auto, if I can find the button. I'm going to key the mic, press auto, and let's see whether it can find anything. All it's found is 922 megs. What's that? A cellular phone down the road. Okay. Well, let's put in 27 as a frequency. It's 27 megs. We'll key it up. Absolutely nothing. So clip that onto the crystal. Frequency 10.24, and we can straight away see that it's picking up the 10.24 reference oscillator for the synthesizer. He says it's 10.2566666 and all that. Well, that's something that works. So I think what we've got to start doing is digging out the circuit diagram and looking for the 8-volt rail. There you are. Right folks, I've printed off the turd kit diagram and I've made some notes on the back of an MOT thing. It says get your MOT to renew the tax on your van. So I looked up the MOT for the van. It says it expired in February and I was driving around in it last week, so you nearly saw me doing videos from prison. So it looks to me like we have pin 10 of the phase lock loop chip just there with a Zener diode at 6.2 volts. So theoretically I should have 6.2 volts there, and I must have, because otherwise surely I wouldn't have had that crystal oscillator running. Now I think it is a chassis which is negative earth on this compact set. Just check that. Yeah. So pin 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that's not right. Oh no, it's the photocopy so bad. It's pin 11, 12, 13, 14. It's pin 18. And there we have 6.4 volts, so that's fine. So that's our first thing. The second thing is, let's have a look at the VCO. And that is resistor 4. I can actually feel something hot. Oh, it could be the, yeah, it's going to be the resistors for the display. So back to the question in hand, that appears to be resistor 4. The far side of resistor 4 goes to pin 17 of the phase lock loop chip. So 20, 19, 18, 17. So the fourth one in on this side, 1, 2, 3, 4. So there's nothing coming out there, and that should find its way around to resistor 4, which is going to be there, and it's going to end up there. Well, I hate to say it, but my first thought here is, have we got a Duff phase lock loop chip? Don't often come up against that, but we've absolutely nothing on that resistor 4. So let's go into transmit. You know, it would help if there was a transmit light on this, but there isn't. just going to unhook this end of this capacitor. That's interesting. Let's put that back on again. I just felt that capacitor feels warm. It's warm now, isn't it? Because I've had the soldering iron on it. Let's unhook that end again. And we'll put the ESR meter on it. No, it's not right, is it? So we'll take it totally out of circuit. And circuit. 33 microfarads. Let's see what we've got. Now for UK, that's not a normal value. So we're looking one of our Chinese sets. We have a Chinese set of capacitors here for Far Eastern repairs. There we go, 33 microfarads. This has all these weird values by British standards. And this is actually higher voltage. .33 microfarads, 16 volts. So we'll just test this with the ESR meter. .9, that's excellent. So we'll now connect that up. Where did I put the old one? I'm just making sure they got negative to the can, which they had. You never know. Clearly there's some timing issue here, so they've had to do this. Right, see what volts we've got now. So switch the radio back on. Oh look, we've got 7 volts there. What have we on the phase lock loop? 0.14. Of course, what might have happened is it's got twiddled. Let's change channel. 40. Just the same. Channel 1. Put the spectrum analyzer back on 27. What's happened there? Put on a monitor receiver. Right, we'll put the extension speaker in because now we're getting somewhere. We can see we've got a VCO that's free running there, which is fair enough. I think that's going to be that's going to have shorted out the output of the synthesizer, and I'm going to change that IC. Now they're expensive, like 14 quid expensive, so let's see where we can find one on a scrap board. We'll turn the power supply off. I think what's happened is that's gone short circuit, it's gone in for repair, somebody's twiddled the VCO, but of course it can't, because there can't be any output because of the short circuit. I've now removed the short circuit, and I think the poor phase lock loop chip has been killed. How often happened, but it's happened this time. We've decided that the set is unrepairable, or certainly not economically repairable. Having done a few capacitors and going through it for dry joints and changing the phase lock loop chip, yet we've had some changes. We're now getting to the realms of it being a repair going over £50. And what I tend to do in these cases is we simply swap the innards of the set with one of ours for a fixed price of 25 quid, done. And that's what we're doing in this instance, and so he ends up with a working set for a small amount of money, and we just use his as a scrap chassis. That's the plan. Mind you, I haven't told him yet. So I think it happens about 1 in 150 cases of 30-odd-year-old sets, and isn't the first time it's happened with a Cybernet 135. So this is now, we're changing to a different chassis. So once again we'll plug our mic in, and his power lead in. We'll start with transmit. We'll go through the I've done the VCO on this, but I will just go through it whilst you're watching. So once again, we're on resistor 4. We're on channel 40. Although I've got no instructions, it's a similar kind of arrangement to the Cybernet 134, so I'm using those kind of techniques. So you can see on channel 40 on receive we've got 3.98. If I go into transmit, we haven't got any transmit. Okay, so we're going to transmit. Do you know, I think we've got a dry joint on this chassis now. Okay, I found a couple of dry joints underneath. Once I cleaned it with isopropyl alcohol, it was something to spot. So we're on transmit, we're now at 3.94 volts. We'll now go to receive, we're at 4.23. We'll just lower that a fraction. And we're going up that way, are we? We'll go down that way then. So that's our transmit, 3.69. See if we can trim that to 4. And the receive 4. Oh, it's about equal there. So now we'll go to channel 1 and we'll check it's in lock. 2.18 on receive, 2.2 on transmit. So that would do. I will taking the test meter with it. Okay, so we now need to now need to look at transmit. All the time I was in transmit there, I'd got no aerial connected. So we'll go through, we'll put the picture in picture on. Check the 3 watt position. Are we on high power or low power? We're on high power. So the radio is currently doing a lousy 1.7 watts. Hang on a minute, I need to be on channel 4, channel 20. It's my usual thing. 2.7 watts. That caused too hot, too tight a dent. Turn it. I must get a hairdryer to do these. I used to have one. Don't know what happened to it. Never used a hairdryer on myself. Man, I haven't got much hair to dry these days. My late father used to go to the barbers, you know, and my late mother told me that when she married him he was 26 and he hadn't got much hair left then. And I said to him shortly before he died when he was 73, I said, are they still charging the same amount to cut your hair? He says, yeah, they're charging me to look for it these days. So it still tickles me, that silly little thing. Is that to transmit one? I can't remember. But we'll twiddle with it, and if it isn't, well, it isn't. It is. Whoa. There we are. That's our power. That's 3.2 watts there. We've got any other cores lurking? Just check that that's maximum. It is. Check the coil stretcher's not been inside. You never know. We don't know the origin of some of these sets. Going to check for dry joints in that area. Right, I've got to the bottom of the dry joint. There's a series power resistor, and it's just here. So if I can waggle that, can't waggle it now. No, it won't move for me now. I've got the video camera on it. Okay, so we seem to have got rid of the dry joints, and we've got 3.2 watts out of it. Seen better, but it's stable. So, what shall we move on to? It's done the transmit. Tune up, we check it on low power, which is a switch at the back. So we'll select the low power reading. We've got absolutely nothing. The presets in these can be bothersome. We can waggle that around, and so too can the slide switch. Okay, we've got it at 150 milliwatts, so I think that's where we're going to say that's where it is. Okay, so move over to deviation, see where we are with that. It's about where it needs to be. Wallow, just a bit quiet. Deviation is there. That one's cleaning as well. Wallow, spot on. So TX meter. So on transmit we want it to light 4 lights. RV4 is the TX meter. And I think it's the lower one of the two. So we just want it to read just the 4. So that's 3, that's 4. That's where we want it. So we'll move over to transmit. Sorry, to receive. Plug the extension speaker in, which is the test equipment. So turn the squelch down. And we're already at 0.45 microvolts for 12 decibel sine wave. So we could say that's fine, but we'll see what we can do. So for a start, we'll put the oscilloscope on, we'll turn the bench light off, and we'll do the detector. I'll put an S9 equivalent signal on, 100 microvolts in the UK for a CB, and time to guess which coil it is. Where's the FM bit? Probably that one. No, it's not. A bit of silver foil in there. It's that one. Surely it is. No, it's not that one either. Could be that one. It is. It needed adjusting as well. There we go. That's that adjusted. Oh, I'm not even showing it you. What a fool. So do that once again. We were about there, and now we are peaked at there. So we'll just go through the front end with the cyanide meter. Drop that to about there. It's alright them filling with wax, but it's best if they're in the right place. This looks to have had a crystal filter put in it sometime. I'm always a bit wary of that, but that's nevertheless what it's got. And that's what we have there. Do you know what? We never checked the transmit frequency. I'm just going to go back on that, because the last thing I want to do is to set up the receive if it's off frequency. So 27,79119. So we'll just pop that up a fraction, but it was so close it won't make any difference. That's fine. Right, we'll go back to receive. Just check that detector just in case it's made a difference. Now we'll go back to where we were. Check there, right, with a bigger signal. Right, now we'll look at where we are with the cyanide. So go back to there. Yeah, we brought that up. So there's 12 dB. So we go now over to the attenuator controls. You can see we've got the small hand, the big hand at 0.3, and we've got the small hand at 0.3. So we're now at 0.3 of a microvolt. So that's better than 0.45. So that's good. So we now have to put S9 on the signal generator and check we've got S9 on the meter. Well, I think we need it to just be touching. I'll tell you what, we'll put it up. Yeah, that's actually exactly where we want it. So I could alter that, which is with the preset there. I could if I was doing the right one. Is it that one then? No. How strange. Is it that one? Yeah, I've gone and upset the. I've gone and upset the transmit one, haven't I? So we just want it. So it's there 3, bit more signal, and you've got the 4. So that's there. We'll just go back to transmit and redo that one for 4 watts. Every time I do that, I have to unplug the extension speaker. I don't know why this chassis does that, but it does. And now it's time for the GB3GR evening, Wednesday evening net. So I'll go over to that for half an hour. Okay, so we're actually on day 3 of doing this set. Between the commitments I've had to do with other work and having to change the chassis on this set, this has gone on and on and on. I think we got as far as needing to do the squelch. Can't even remember whether we did. Anyway, we're doing the squelch. I've just turned it up to full on the radio, and the idea is that we should have 100 microvolts to open it, and that's 30, so it's too light. But I messed about with one of the presets, didn't I? And RV3 is that one, isn't it? It is. There we go. 100 microvolts to open it. So we've done it. So I'm going to start putting this radio together. Okay, so we're actually on, I think, day 4 of this radio, because I just can't get onto it. And finally we've got to the stage where we're going to plug it into the aerial. So we will unplug it from the test instrument. Just check the internal speaker works. Yep. Mind you, it sounded alright on his previous set and it wasn't. Got his original mic, does work even if it's broken. One Anna, Roger. Right, we'll put out on 31, ready for a test round scratchy corner, and that's another job then done. So it's been a bit long-winded, and we ended up swapping the chassis because of it's not that they're impossible to fix, but as commercial two-way radio engineers, we don't really want to be spending more than 90 minutes on sets, or they become just unviable. And the trouble is, if you've got parts that have failed in the wax department, you know, starting to melt the wax out and all that, so rather not. So he gets a cheaper outcome and a better set. So there you have it, Cybernet Beta 1000 from 1981.